Okay, so this video is going to show you the solution for the first example in the sample problems in our second module for instrumentation and control. So this is now the problem. Calculate the required series resistance for a 10-volt AC meter that uses full wave rectification if the meter movement is rated 1 mA, 500 ohms, and the shunt resistance is 500 ohms, and the forward biased resistance of each of the diodes is negligible. So if we're going to draw now the diagram based on the circuit of a voltmeter with full wave rectification. So I hope you have read your handouts already. So for a full wave rectification, it makes use of a bridge. So we have 4 diodes this time. There. So arranged that way. And the terminals at the vertical corners will be connected to your input, or technically these are your probe terminals right here. And then the horizontal corners is where you're going to connect your meter movement, but we have a shunt resistance there. So we have, I guess we have similar values for the resistance of the meter movement to the shunt resistance connected. So what are the values? It's 500 each. So this one is 500 ohms. And this one is also 500 ohms. There. The full scale current is said to be 1 mA. And this is now the series resistance we are looking for. So what we want is, if this range is 10, so this must be 10 volts in AC. So we want our instrument to operate so that if an input AC voltage of 10 volts is tapped across the terminals, so again, these are technically your probe terminals, then the meter movement should deflect full scale, and the meter movement will only deflect full scale if the current passing through it is 1 mA. Remember also that the 1 mA current here is in DC. So the input is AC. The current here is in DC. So again, we must consider that this is going to deflect according to the average value of the AC input. However, since this is now full wave rectified, we know that the sensitivity of the meter compared to the sensitivity of the DC meter is 90%. So it's just 90% sensitive. We did the same computation also for half wave rectification, very similar to this one. So what we know is, in getting the sensitivity, I will not explain this again, kindly refer to our first couple of videos. In getting the sensitivity, we must take the total current and not just the current passing through the meter movement. So we have to get the IT here. And the total current in DC should be equal to, if this is 1 MA, and since they are of the same resistance, also we have discussed this from the previous video, so it's common sense that this should also be 1 MA, so that the total current here in DC must be 1 MA plus 1 MA, which is of course 2 MA, which means to say our sensitivity in DC must be equal to 1 over 2 MA. But our AC sensitivity is 90% of that. So our AC sensitivity is 0.9 of the reciprocal of 2 MA. So if we're going to calculate that, 1 divided by 2 exponent negative 3 is 500 multiplied to 0.9, that must be 450. So same formula here, guys, nothing new. SAC multiplied to the V range must be equal to the total resistance. So if we substitute, SAC is 450, the desired range is 10 volts. Or is it? Yes, for a 10 volt AC meter. So range is 10 is equal to, so what is now the total resistance? So we will be neglecting the forward biased resistances of the diodes according to the problem. So if we're going to neglect those forward biased resistances, then the only resistances left for us to analyze are the 500 ohms, the 500 ohm resistance of the meter movement, the 500 ohm shunt resistance, and the series resistance. So neglecting this bridge, the circuit will fundamentally look like RS in series with the parallel combination of 500 and another 500. So as seen by the input, the total resistance is RS plus the parallel combination of 500 and 500. There. So simplifying, this must be 4,500 is equal to RS plus 500 in parallel with 500 is 250, I guess. So the required series resistance to implement this is 4,500 minus 250. So that's 4,250. There.